So good afternoon, students. Good afternoon. Good afternoon, one and all. So am I audible and visible to you guys? Anu, Jyoti Lakshmi, Ashwin, am I audible? So can you able to see me on my screen? Yes? Yeah. Thank you so much, Anu. So students, today we are going to start with the very first chapter of chemistry, class 2. Okay. So which is solutions. So here in this lesson, as I have already told you yesterday, this is one of the physical chemistry lesson in which you will have formulas, okay, and a lot of numericals will be solved, okay. So coming to the lesson, coming to the brief introduction of solutions. So I would just like to tell that in our daily life, we come across many substances, right? For example, salt in water and sugar in water, and we come across the air, paste, injection, etc., trumpets, etc. So these are the substances we come across in our daily life. Okay. Now, most of the substances are mixtures containing two or more pure substances. Okay. So most of the substances are the mixtures containing two or more pure substances. Like if I take a salt solution, it consists of two components. One is a salt and the other one is water. So it consists of two substances. So two or more than two can also be there. Now, can you guess which of the following picture which I'm going to give you or show you are solutions? Okay. So the first is sugar solution. It is a solution, we all know. And the next is brass. And you have to tell me whether it is a solution or not. And the third picture I'm going to show you is air. Okay. Now you tell me whether brass and air are the solutions or not. What do you say? What do you think? What do you guys think of it? Whether it is a solution or not? Tell me. Can you guess which of these are solutions? First one is a sugar solution. Okay. What about the second and the third one? Any idea? Tell me whether brass is a solution or not first. Then we will go to air. Say yes or no, or say that it is a solution or it is not a solution. So give me some answer. Don't get scared, okay? Don't get scared. Again and again I'm saying it. Don't get scared. Just give me the answer. We are not going to scold you if you are going to give the wrong answer, okay? Just give a try. So Ashwin is saying brass is not a solution. Okay, what about the air? What about the air? Any idea about air? No idea? Okay. So we'll see the answer now. All the three are the examples of solutions. Okay, all the three are the examples of solution. Okay. Now you might be thinking, ma'am, how it is a solution, how brass will become a solution, or how air will become a solution. So now let's see about it. How they are called a solution, that you will understand at the end of this today's class. Okay. Now what are solutions? So the definition for solution is the homogeneous mixture of two or more than two component is called as a solution. What it is? A homogeneous mixture of two or more than two component is called a solution. Okay. So the component may be solid, or it can be liquid, or it can be a gas. Okay, it need not be liquid all the time. It can be a solid, or it can be a liquid or gaseous state. So that's why you guys have confused in the last question which I have asked. Since brass looks like a solid, you might have thought like brass could not be a solution, etc. Okay, so the component may be solid, liquid, or gas. Now, what does mean by homogeneous mixture? What is a homogeneous mixture? So let's see about this. Homogeneous mixture means the composition and physical properties are uniform throughout the mixture. The composition, and the composition means the chemical formula. Okay. So if we are having sugar, then the formula is C12H22 and O11, right? So that is a composition of sugar. And the physical properties like melting point, boiling point, solubility, mass. So those are the physical properties. They are uniform throughout the mixture. If it is uniform throughout the mixture, then that particular mixture is called as homogeneous mixture. Okay. Now let's understand it. So to understand this, so what you do, take a spoon of sugar and mix thoroughly in a glass of water. Take a sugar and mix thoroughly in a glass of water. So what you do, you check whether the taste of every drop is same or not. Will it be same or it will not be same? What do you guys say? Will it be same? If you take a drop of this sugar solution and if you taste it, will it be same? The taste of every drop? Yeah, very good. It will be same. It will be same because it is a sugar solution now. It is not separate water and sugar. Now it is a sugar solution. So since the composition is uniform throughout the mixture, we are calling that as homogeneous mixture. Okay. Now coming to the definition for solution again. Solution is a mixture of solute and solvent. Solution is a mixture of solute and solvent. Okay, solution is a mixture of solute and solvent. So in the last example which I have given, in that sugar is the solute and water is a solvent. Okay. Now how to find out the solute and solvent in all the cases? The solute means the component which is present in very lesser amount or in which is present in very smaller quantity is called as a solute. Okay. The solvent is just the opposite of this solute. The component present in larger quantity is called as a solvent. Okay. The component which is present in smaller quantity is solute, larger quantity is a solvent. Okay, students. So students, by the way, if you are noting it down in your notebook, you all have to note down in your notebook. Okay, and if you need time or if I change the slide before you write, just let me know. So I'll wait for you for some time. Okay, so that you can take down the notes from the slides from the PPT which you are seeing. Okay, so is everything okay till now, right? Or you want to write any definition, or if you want to write something before, which I have taught from the previous slide. If you want me to show any slide, I can show now. So I'll give you 1 minute for that. If you need any definition, so let me know. I'll show you that slide. So first we have seen the definition for solution. So that is very important. And the definition for solute and solvent is important. Example, you can take sugar solution. Okay, clear? Shall I move on to the next slide, students? Shall I move on to proceed with the next slide? Yes or no? Shall I go with the next slide? Yes. Okay. So now you have to identify the solute and solvent in the given solution. Okay. So I'm going to give you a question. It is a solution of 5 grams salt in 1000 ml water. Now you have to find out which is a solute and which is a solvent here. First, tell me which is a solute here in this question. Which is a solute? Tell me which is a solute here. Salt, very good. 5 grams salt is a solute. The salt is a solute. Very good, very good. Who have given me that answer? Yeah. It's Aju and Anu. Very good, students. Salt is a solute. And what about the solvent? Who is the solvent here? Very easy, na? Who is the solvent? That's all. Water is a solvent. Water is a solvent and the solute is a salt. Very good. All these things are very easy only. Now one more question for you guys. So it is a solution of 5 ml ethanol in 500 ml water. Now find out which is a solute here. Which is a solute? Ethanol is a solute or water is a solute? Very good. Very good, students. Very good, Jane Vianam. Good. Ethanol is a solute and the solvent is the water. Very good. Very good. Now I'm going to give you a note. So in the above two solutions, if you see, the solvent is water. Okay. The solvent water is called aqueous solution. If your solvent can be anything. It need not be the water all the time. Okay. It need not be the water all the time. If it is if the solvent is water in our system, then we call that particular solution as aqueous solution. Clear? All these are the very basics. Okay, you should not get confused or you should not know about these things and all. So you should be very clear enough in all these concepts. Okay, if you are so in a solution, we have a solute and we have a solvent. If the solvent is water, then we call that solution as aqueous solution. Clear? So let me move on to the next slide. I'll keep on changing like this. So if you want me to stop anywhere, just let me know in the chat box. I will stop there. Yeah. Now next we will go for the classification of solutions. Let us classify now. So solution can also be classified based on the number of components. Okay. So it is classified first based on the number of components. So if the number of component is equal to 2 or if it is equal to 3, if it is equal to 4. If it is equal to 2, then we call that solution as it can be equal to 2 or 3 or 4. Okay. It is bi, 3 means ter and 4 means quarter. Binary solution, ternary solution, quaternary solution. Okay. The component may be anything. And it is also classified based on the physical state of solute and solvent. It is also classified based on the physical nature, appearance of the solute and solvent. Okay. Now we are going to discuss about that second classification, which is based on the physical state of solute and solvent. So for this, I am going to give you a tabular column. So the first column is about solute, next is solvent, third is types of solution, and fourth, we are going to see the examples for each type. Okay. So the first thing is the solute is going to be a gas and the solvent is going to be a gas. So gas solution we are going to see. Okay, the type of solution is called as gas in gas. The example can be air. Air is an example for gas in gas solution. Initially, I have shown you one picture now for air. So that is also an example for solution. The type is gas in gas. So I'll give you a picture. So you can see gas in gas. Then the next type is gas in liquid. Gas in liquid. So examples are oxygen in water and carbonated drinks, all soda, all Sprites, Coca-Cola, everything, etc. So there you can find the oxygen in water. So oxygen is a gas, and water is a liquid. So gas in liquid. Okay, it is also an example for solution. Okay. Carbonated drinks, if you see, carbon dioxide will be the gas there and water is a liquid. So gas and liquid. So it is an example. Then the third type is gas and solvent is a solid. So gas and solid. So what can be the examples for this? Adsorption of hydrogen by nickel, platinum, palladium. So here nickel, platinum, palladium are the D block metals. Metals means they are the solid component. Okay. And hydrogen is a gas. Hydrogen is a gas. Now the hydrogen gas is going to get adsorbed on the surface of the solid. Okay. Adsorption means accumulation of that particular substance on the surface. Okay, it will not get observed, it is getting adsorbed. It will be present only at the surface. It will not go inside that particular thing. Got it? Now I'll show you the picture, you can understand. So we have a metal and the hydrogen gas is getting adsorbed on the surface of that metal. So it is also an example for solution. So gas and liquid solution. Okay. Now the next fourth thing is solute is going to be the liquid and solvent is going to be the gas. So initially what we have taken solute as gas. In the first three types, solute was taken as gas and we have changed the solvent. Now the solute is going to be the liquid and going to change the solvent. So first is gas. So it is an example for liquid and gas. Example is evaporation of liquids, moist nitrogen gas, liquid in gas. So you see here, evaporation of liquids, moisture, nitrogen gas. Okay. And next is solute is liquid again, solvent is also a liquid. Liquid and liquid. Liquid and liquid means ethyl alcohol and water. Like in all the drinks we are having, no, ethanol is dissolved in water. So water is there and ethanol is getting dissolved. So both of them are liquid here. Okay, ethyl alcohol in water. And in the third case for solute as liquid, solvent is taken as solid. So this is a liquid and solid type. And the example is mercury in silver. Mercury. Mercury is a metal, but it is the only liquid metal. It is a liquid metal. You might have seen mercury at the tip of the thermometers, right? Has anyone noticed when you are going to hospital for fever or some other thing, or if you have seen the thermometer in your school labs or somewhere, you might have seen one some liquid kind of metallic color component at the tip of the thermometer. Has anyone noticed? Has anyone noticed before? So that is nothing but the mercury. Okay, it is a D block metal. So now that is in silver. Silver is a solid. Silver is a silver metal is a solid metal. So liquid is present in solid. So it is an example for liquid in solid type of solution. Okay, so silver metal and above that we have a liquid, mercury. Now the third set. So in the first set we had gas as solute and the second set we had liquid as solute. Now in the third set I am going to take solid as solute. I am going to change the solvent. First is gas. So type of solution is solid and gas. Examples are iodine and nitrogen, evaporation of camphor. So who is this iodine? Liquid, solid or gas? It is a solid. Iodine is a solid and nitrogen is a gas. So solid and gas. Solid and gas, you see. Evaporation of camphor. So camphor is a, what to say, solid that will get evaporated. Okay, in the air. So it is an example for solid and gas. Then the second thing is liquid. Solid and liquid. So example is sugar solution or salt solution. Sugar or salt is a solid. Okay. And water is an is a solvent. So solid and liquid. Solid and liquid. Sugar solution or salt solution. Then coming to the last type, solid and solid type. So the example is metal alloy. Metal alloy. What is an alloy? Two or more metals combines to form an alloy. Okay, two or more metal combine to form an alloy. So in that case, both of them are metal. So both of them are solid. So it is an example for solid and solid type. So you see here, bronze. Bronze is taken. So it was one of the first alloys created by human. Okay, so it is an alloy, which is a solid in solid mixture. Bronze, brass I have shown you in the beginning, no? So it is also a solution of a solid in solid type. Okay, clear? So how many types we have discussed? Totally 9 types we have discussed. So in the first case, I took a gas, then gas liquid and gas solid. Okay, this is first set. Then in the second set, liquid was taken as the solute and the gas was taken as the solvent. And in the second case, liquid with liquid. And in the third case, liquid with solid. Okay. Then in the third case, solid is taken as a solute, solid and gas, solid and liquid, and solid in solid. Okay. Clear for all? Clear? So what you need to do, you have to study all the 9 types with example. Okay, like in the question paper, they may ask like this. Which among the following is an example for solid and solid type? Okay, so this can be the question and they will give you 4 options from 4 different examples they can take and give you and you should be able to find out. If you understand the concept, you don't have to worry. You don't have to memorize or you don't have to worry about it. Okay, like if I'm saying gas and solid, if I'm saying gas and solid, you don't have to think of or you don't have to recall the thing which you have memorized. You can immediately go to hydrogen, which is getting absorbed on the metal surface. Okay, so immediately you can go for it if you are understanding the concept. So I hope this is clear to all of you. So do you have any doubts from the classification part which we have discussed now? Is everything clear so far for all the students who are watching here? Yes? No? No. No, ma'am. Jayanam, do you have any doubts? Oh, for that question only you have said. Okay, okay, fine, fine. No issues, no issues. Understood, understood. Got it, got it. Sorry, sir. Okay, fine. Now let's move on to the second topic for today's session, which is called as concentration terms. Okay, so firstly, we have discussed some of the introduction and the next main topic is classification. Now, the third topic for today's class is concentration terms. Okay, so which is a very important part. So, concentration. So, before moving on to the definition, I would like to ask you something. So, what you do, consider 2 beakers which contain solvent like water. So, what you do, take 2 beakers and they both contain solvent like water. Water is a solvent, no? So these two can be water and cannot be the water. Okay, take 2 solvents which contain these two. Now what you do, let us add solute like salt in both the container but in different quantity. What I'm going to do, I'm going to add salt or sugar, anything. We can add salt here but with a different quantity. Suppose in the first beaker, if I'm adding 10 gram of sodium chloride salt and the second beaker, I have to add 30 gram. I'm going to add 30 gram of NaCl. Okay. Now I am going to ask you a question. Tell me which solution will be more salty? First solution or second solution? Very good. It is the second solution. Why? Why is it is more salty? Why it is more salty? Because more quantity of sodium chloride is present. Solvent amount is same. Let me take the amount of solvent as like 50 ml or 100 ml also we can take. So in both the beaker, solvent quantity remains same, only the solute quantity is differing. So the beaker which contains more amount of solute will be more salty. So that is a reason. Very simple and easy thing here. Now, because we can also define this more quantity of NaCl as the concentration of NaCl is more. We can classify or we can denote this quantity as concentration. Okay, more quantity in the sense concentration of sodium chloride is more in case of second beaker. So what is the concentration now? Concentration of solution is the amount of solute dissolved in a known amount of solvent or solution. Okay, it is called as concentration. Known amount means that 100 ml. I already know the amount of the solvent, no? 100 ml. So, in that 100 ml, the amount of solute dissolved denotes the concentration of that solution. Okay. Now, what is the meaning of dilute solution? Any idea? What is the meaning of dilute solution? We have two different solution. One is dilute and the other one is concentrated solution. Now I am asking you, what is the meaning of dilute solution? Very good. A solution, the solution in which solute is present in very small quantity. JNV Anand students are saying where the concentration is very less. Oh, that is also the correct answer only. But little bit looks funny, okay, when I see that. Okay, no issues, good. A solution in which solute is present in very small quantity is called as a dilute solution. Okay, what is the meaning of concentrated solution? What is the meaning of concentrated solution? A solution in which the solute is present in large quantity. Which the solute is present in, yeah, more solute particles. Very good, students. The solute is present in large quantity is called as concentrated solution. Good. Now one more question. Which way is better to describe the solution if I give you the options? The options are qualitatively and the other one is quantitatively. Which way is better to describe the solution if the options are qualitative and quantitative? So I would go for quantitative. Okay, so that would be the better thing to describe a solution. Quantitatively means based on the amount of the solute. Based on the, no, it is number 2. Okay, based on quantitative means based on the amount, quantity. Okay, based on the quantity of the solute which is present inside the solution, we can describe the solution in a better way. Okay, so now let's go with the next thing. Can concentration be expressed in one way, two ways, or many ways? What do you all say? Can concentration be expressed in only one way? Or it can be expressed in two ways or more than two ways? What is your answer? I need the answer from the student side. Two ways. What are those two ways? What are those two ways? JNV Anam students are very enthusiastic and giving me interacting in the class very well. Good and great. Qualitative and quantitative. No, that is not the thing to. Very good. Many ways is the correct answer. Good. JNV Anam students have tried. Great for that. So, admin. So, may I know the person who is sitting behind the ID admin, or is it a school? JNV Shimo. Okay. Fine. Good. JNV Shimoga, you are doing great. So, many ways is the correct answer. Concentration can be expressed in many ways. The most commonly expressed concentration terms are, and what are those many ways only I'm going to say, okay? So they can be expressed in terms of mass percentage. Concentration can be expressed in terms of volume percentage, mass by volume percentage, parts per million, which is ppm, mole fraction, molarity, molality. So concentration can be expressed, yeah, very good. Mole fraction is one of the concentration. So concentration can be expressed in all these 7 forms. Okay. So what we are going to do next is, we are going to take each and every concentration term. Then we are going to see one formula under each term. and we are going to apply those things in the numericals. Okay, so let's start. So any doubt so far for anyone? Do any of you have any doubt from the introduction to concentration terms part? We can proceed, right? Shall I proceed with the next slide? Yes? Quickly, quickly. Yes or no? Yes. Thank you, Anu. Now coming to the first two term. Yeah, everything will come under quantitative only. Everything depends on the amount of the solute only. Okay. Yes. So the first two terms are mass percentage and volume percentage. So coming to the first mass percentage, it is denoted by W by W percentage like this. And the definition for this is the amount of solute in gram present in 100 gram of the solution. Okay, we can write this whole statement in a mathematical expression like mass percentage of the component is equal to mass of the solute divided by mass of the solution into 100. Okay, so this is the formula. Either you memorize this formula or study this formula. Study this definition or this formula. So I would suggest you to go for this formula so that you will not get confused. Okay, but you should be able to write this definition also if mass percentage definition is asked to you in your school exams. Clear? You're not going to get this type of definition question in NEET exam or JEE exam, but when it comes to school exam, you should be able to write the definition from the formula which you have studied. Got it? So this is the formula for mass percentage. So have you all noted this down? Shall I move on to the next slide? Mass of the solute by mass of the solution into 100. Okay. So the next thing is, what do you mean by? I'm going to ask you a question. You're going to try. Okay. What do you mean by 35 percentage mass by mass glucose solution? What do you mean by 35 percentage glucose solution? Any idea? In terms of mass percentage, how will you tell this? Do any of you have any idea or do you know the answer for the meaning of 35 percentage glucose solution? Okay, it means 35 gram of glucose is present in 100 gram of solution. So the definition we have seen, no? 35 percentage means 35 gram of glucose is present in 100 gram of the solution. So what is the weight of glucose there? 35 gram is the weight of the glucose. What is the weight of solution? 100 gram is the weight of the solution. So what could be the weight of solvent? How to calculate the weight of solvent here? Weight of solution minus weight of solute, right? Because solution is nothing but solute plus solvent. Now, if I want to find out the mass of solvent, what I have to do? It is solution minus solute. So that's what we have done here in the slide. Yeah, very good. It is weight of solution minus solute, 100 minus 35, which is equal to 75. Sorry, 65. Yeah, 65. Great. Good students. Now let's move on to one more question. Calculate the mass percentage of benzene and carbon tetrachloride if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride. So this is a question. How to approach this question? We have two components. Okay, one is benzene and the other one is carbon tetrachloride. So here we have to find out which is a solvent and which is a solute. So let me take benzene first and carbon tetrachloride. So benzene is a solute here and carbon tetrachloride is a solvent here. It is a liquid. CCl4 is a liquid. Now what are the given values? First write that. The benzene formula is C6H6 and the carbon tetrachloride is CCl4. Okay, 22 gram of benzene. So what is this 22 gram? It is the mass. It is the mass of benzene. So mass of, let me take this benzene as component A and CCl4 as component B. So mass of A is equal to 22 gram and 122 is the mass of CCl4. So the mass of the component B is equal to 122 gram. Okay, these are the given values and from this we have to find out the mass percentage. So mass of the solute, which is benzene, it is equal to 22 gram and the mass of the solvent is equal to 122 gram. Now the mass of the solution is solute plus solvent. So 122 plus 22, which is equal to 144 gram. So this is how we are calculating the mass of the solution. So why did I find out this mass of the solution? Why I have found out this? We should calculate the mass percentage in the question. So to find out the mass percentage in the formula, mass of the solute by mass of the solution into 100. Okay, we have mass of the solute and mass of the solution into 100. So we have solute mass, we don't know the solution mass and that's why we have calculated the mass of the solution. Now what you do? Calculate the mass percentage using the formula which we have studied. Mass of solute by solution into 100. So it is equal to 22 divided by 144 into 100. So what will be the answer? What will be the answer? Has anyone got the answer? By solving this, just multiplication and division, no? All of you try for the answer and let me know the answer in the chat box. At least give me the approximate answer. Very good, very good. It is 15.28%. It is the mass percentage of the solute. But we have to find out the mass percentage of both benzene and carbon tetrachloride. Solute is benzene, we have got it. Now what is the mass percentage of solvent, which is CCl4? There are two ways. The first way is what you can do. Go for the mass of CCl4 divided by mass of the solution into 100. Either you can use this formula or what you can do 100 minus 15.28. If you do 100 minus mass of the solute, you will get the answer. Okay. You subtract 15.28 from 100, you will get one answer. That will be the mass of solid. So this is the second method to solve. Clear? I hope this question is clear to all of you. Am I right? Shall we go with the next concentration term, students? Yes? Yes or no? Is everything clear so far? Mass percentage concept? Yes. Now coming to the volume percentage. It is denoted by V by V percentage and the definition is volume of solute in milliliter present in 100 ml of the solution. It is called volume percentage. So volume percentage of a component is equal to volume of the solute by volume of the solution into 100. So instead of mass, you substitute volume. So that is the only difference between the first formula and the second formula. Okay. Now the question, do you want to take down? Do any of you need to take down this formula? If anybody is taking down, take down fast. Maintain a proper notes from the first class onwards. Okay. So maintain a notebook, follow that so that it will be useful for you in the upcoming days. So don't write the notes here and there. Maintain a separate notebook for chemistry and follow each and every class and the notes of every class. Okay, and revise it every day. As I have said yesterday, consistency is very, very important. Okay, shall I move on to the next thing? Okay, I'll move on. Question. Can you tell what is meant by 100% ethanol? Sorry, 10% ethanol. Can you tell what is 10% ethanol means? What is your answer? Present in how many milliliter of solution? 10 ml of ethanol. Very good. Very good. Very good. So 10 ml of ethanol present in 100 ml of aqueous solution is the meaning. Very good, students. Very good, Anu. Very good. Now, the next is mass by volume percentage and parts per million. So we have seen two concentration terms. Now we are moving into the third term and fourth term. So the third term is mass by volume percentage. It is denoted by W by V. It is the mass of solute in grams present in 100 ml solution, or it is the mass of solute dissolved in 100 ml of the solution. Both are same only. Okay. So the formula is mass of solute divided by volume of solution into 100. So take the numerator from first formula and the denominator from the second formula and put it 100. Put 100 here, you will get the third formula. Okay, mass by volume percentage. Very easy. You don't have to get confused here. Okay. So now the question is, what is meant by 100% W by V? What is meant by 100% mass by volume percentage? What is the meaning? Very easy, no? Tell me quickly. It is 10 gram of solute present in 100 ml of the solution. What it is? 10 gram of solute present in 100 ml of the solution. Now with the same concept, I would like to go with one more question for you guys. It is, calculate the mass by volume percentage of NaOH when 10 gram of NaOH is present in 100 ml of a solution. How to do this? How to find out the mass by volume percentage of NaOH? So we know the formula, mass of solute by volume of solution into 100. Now we need mass of the solute. Do we have the mass of solute in the question? Yes. If we have, what is the value? What is the mass of solute? Who is the solute here? Sodium hydroxide is a solute. Very good. Sodium hydroxide is a solute. It is a pellet kind of thing. Okay, so it is a solute. So the mass of solute is 10 gram. Answer is 10. Okay. So mass of solute is 10. Volume of the solution is 100 into 100. So the answer is 10 gram. Very good, students. Very good. So we'll move on to the fourth concentration term. You guys are doing great. So the fourth term is parts per million. So when a solute is present in very, very small trace quantity, then it is convenient to express the concentration in parts per million term. Okay, if it is present in grams or kilograms in that term, then we can use the other concentration term. If the solute is very, very, very small, okay, the amount of the solute is very, very small, then you can go for this ppm. Like formula for ppm is equal to number of parts of the component divided by total number of parts of all the component into 100. Sorry, into 10 to the power 6. Into 10 to the power 6. It is million, right? So it is 10 to the power 6. So take down the formula. Number of parts of that component divided by total number of parts of all the component into 10 to the power 6. This is the formula. Now, for example, the concentration of dissolved oxygen in a seawater can be expressed in ppm, because seawater, if you take, it is what to say, it is a huge amount, you know. So the amount of oxygen is a gas. it will be very, very less. So it can be expressed in terms of ppm like this, in this unit. And the concentration of pollutants in water. So pollutants amount will be very, very less in water or in atmosphere. It will be very, very less. So we can express that in terms of ppm. We can see here, water is more and the pollutants, the dirt, they are very less, no? So we can express this in terms of ppm. With this, ppm is getting over. Then the next topic is, next concentration term is mole fraction. Mole fraction is the fifth concentration term. So it is denoted by the letter X. Okay. Definition is the ratio of number of moles of one component to the total number of moles of all components present in the solution. I'll give you the formula. It will be more easy. Before that, I will give you an example. So in a binary mixture, if you see, binary mixture means only two components will be there in a solution. So I'm taking the two component as A and B. If the number of moles of A and B are Na and Nb, then the mole fraction of A will be, mole fraction is denoted by the letter X. And if I want to find out the mole fraction of A, I have to denote it by Xa. It will be equal to number of moles of that component, which is Na, divided by total number of moles of all components. All means we have only two components in the solution. Total number of moles means it is Na plus Nb. Is this clear now? So if I want to find out Xb, what I have to do? What will be the formula? If I want to find out Xb, number of moles of B divided by total number of moles. That's all. Okay, very easy but very important. So this is the formula for the mole fraction. Yeah, 1 minus X also you can do. So what we can do, sum of the mole fraction will be equal to 1. So sum of the mole fraction means for this binary mixture, Xa plus Xb will be equal to 1. Okay. So if I want to find out Xb, what I can do? I can do 1 minus Xa. So this is also one of the formula. You have to note it down. Take down this also. Very good, students. So now moving on to the next slide. So it is very useful in relating some physical properties of solutions like vapor pressure, etc. in terms of mole fraction. And the very important point about mole fraction is it has no units, because it is a ratio, no, of the number of moles. So it has no units. And the next point is it is independent of temperature. These 2 points are very important to note down. So take a note of it. It has no units and it is independent of temperature. Okay. Shall we move on to the next thing? Are you all awake and ready? Yes? Yes. Only JNV students are awake, I think. Huh? What about the others? Others are also awake, but they're staying silent, I think. Okay. So let me move on to the question. Calculate the mole fraction of benzene in a solution containing 30% by mass in carbon tetrachloride. Again, the same components, no? Benzene and CCl4 is coming. But we have to find out the mole fraction now, which is of benzene. Mole fraction of benzene we have to find out. Component A is benzene. Component B is carbon tetrachloride. We have to find out Xa in a solution containing 30% by mass in carbon tetrachloride. How to find out? A is equal to 78. Okay, the mass of the solution, I am taking first. Mass of the solution is 100 gram. 30% means 30, B is 154. Mass of the CCl4 is equal to 70 gram. And mass of benzene is 30 gram. So benzene is a solute and CCl4 is a solvent. So solution means 30 gram. Okay. Solution means 70 plus 30, so 100. Now, next I am going to take out the molecular mass So why I'm going to find out the molecular weight or molecular mass means to find out this mole fraction, we need number of moles of A divided by total number of moles, right? So number of moles is equal to the given mass divided by molar mass or molecular weight. So this is the formula. Number of moles can be calculated using given mass by molar mass. So that's why we have taken the given mass of CCl4 and mass of benzene. Now we need the molar mass, which is nothing but the molecular weight of both the components. So how to find out the molecular mass of both the components? So for CCl4, how will you find out? For carbon, atomic mass is 12. And for chlorine, atomic mass is 35.5. But we have 4 chlorine. So what we have to do? We have to multiply this by 4. And if you calculate this, you will get 154 as the answer. Molecular weight of CCl4. Okay. Okay, let's see. Now coming to the molecular weight of benzene. So we have 6 carbon in benzene. So 6 into 12. So 1272 is the mass of mass of carbon, and also we have 6 hydrogen. So for each hydrogen, the atomic mass is 1. 6 means 6. 6 into 1 is 6. So 72 plus 6 will be 78. So 78 is the molecular weight of benzene. So I have both the molecular mass value as well as given mass value. So we can directly substitute. So the number of moles of benzene is equal to mass of benzene by molar mass of benzene. The given mass of benzene is 30, molar mass is 78. The answer is coming out to be 0.385. And now coming to the number of moles of CCl4, it is 70 divided by 154. So it is 0.454. The number of moles are ready. Just substitute in the formula. So what we have to do? XA is equal to number of moles of A divided by number of moles of A plus B. So Na is 0.385 divided by 0.385 plus 0.454. So this is what you have to do. Okay, so let's do. The mole fraction of benzene is the same thing which I have written. So if you calculate everything, you will get 0.4583 as the mole fraction of benzene. Okay, so this is how we have to solve this question. This looks little bit what to say lengthy. Okay, because this is the first time we are solving, no? So this looks little bit lengthy, but it is very easy. If you are practicing it, it will become very easy. You can directly substitute the thing in the formula and get the answer very quickly. Okay, you need to spend some time, okay, some seconds in multiplication and division, that's all. Otherwise the chemistry part is very easy here if you know the formula. Okay, so here the mole fraction term is getting over. So how many terms we have discussed today? Can anyone tell me how many concentration terms we have discussed? Totally we had 7, and out of 7 we have discussed 5. The first is mass percentage, second is volume percentage, third is mass by volume percentage, fourth one is parts per million ppm, and the fifth one is mole fraction. The remaining 2 are molarity and molality. So those 2 terms we can discuss in the tomorrow's class, and we can move on to the next topic. Okay, so today let me summarize the topics which we have discussed. So first I have given you some introduction about the solution. Okay, introduction to solution was done. And secondly, we have seen the classification of solution in which 9 types were discussed over there. And thirdly, we have discussed the concentration terms. So 7 terms are there, and we have discussed 5 among those 7. Okay, so remaining 2 we will discuss in tomorrow's class. So do any of you have any doubts from the today's session? Do any of you have any doubt from today's session? If you are having any doubt, you can put that in the chat box. Otherwise, we can wrap it up the today's session. 0.5417 is the mole fraction of CCl4. Very good. Very good, JNV students. Your answer is correct. But in the question, we are asked to calculate only the mole fraction of benzene, right? So that's why I have calculated only for benzene. Your answer is correct. So if you do 1 minus 0.45, you will get this as the answer. Correct. So no doubt for the students who are listening the lecture. Okay, then we can wind it up. So thank you so much for listening the lecture, students. Meet you all in the tomorrow's class, sharp at 3 p.m. Okay. Thank you, Anu. Thank you so much, students. Thank you. Take care. Bye bye. Take care.